Good morning, everyone. Today we're going to introduce another lesson related to function, which is called interpret function. In this lesson, we are going to discover something about function notation. Before we start the lesson, let's have a quick review. So in front of you, you see the three pictures here. So I try to recall when we see the graph, how do we determine if this is a function or not? Also, you can definitely pause the video and think about the answer and then compare the answer with me later. So for these functions here, for these graphs here, because we don't know if this function, if you recall this, you'll probably figure out the way we determine if this function or not. We use, yes, you're right, vertical line test. What does that mean? Very straightforward. We draw a vertical line and we see how many times they intersect. Twice. This is not a function. Twice. It is not a function. Some students might argue, but if I draw here, only touch once. See, that's the thing. When we use a vertical line test, we draw one line. Multiple lines, doesn't matter. But if we say one non-cases, like intersect more than once, then it is not. Even there's one line pass the test, it doesn't work. For this one, no matter how many lines we hear, this is a function because there's no more than that. Okay, so that's just quick review for determining if the graph represents a function or not. So let's check another scenario. For this time, we're looking for a real life situation. Again, you can pause it and read the scenario here and to see if you can create a function to find the fees you need to pay the plan. Again, my suggestion is pause the video here and figure out what it is. So for this one, as we know, some of you always write y equals. So based on this one says we need to pay a flat fee, $5. So this one is every single month is you need to pay 5. It's not changing. This one, you need to pay 10 cents for each song. So that means how much you need to pay really depends on how many songs you are downloading. So that's why, let's say I download X songs. So how many you need to pay? Someone might say, hey, 10x. So some students already notice it's a mistake because since we're talking about dollars, you need to make 10 cents also converted to a dollar. So it's going to be this. So let's put that. That means how many songs you need to, depends on how many songs you download. So in this situation here, with Y represent the final fee into pay each month, X represent the number of songs you downloaded. So here is saying in real life situation, a lot of cases is we talking about different. For example, this is talking about the fees, and sometimes we're talking about like the number, or for example, sometimes when you start a school, some teacher need to figure out how many books I need to order, those kind of thing. So in real life situation, we have different scenarios. So this time we prefer use a different letter to represent it instead of just using Y. So this case, we're actually using f of x, and this is exactly same as y. So this is something we are going to discover today, which is called function notation. Let's check another example about the ways to represent function. In this example, we use an equation to represent function, but in this way, in this slide, we actually see how many ways we can represent, like multiple ways. We can use a table, we can also use a graph. This one we just call equation, like the one we just did. So all three ways represent function, and every single one here, we can use a function notation to discover what are the facts you notice from this one. So as I mentioned, function notation is instead of using y, we're using f of x. It's just, for example, I can use g of x, I can use c of x, I can use multiple letters. This is basically telling us this is a function about x, but g and c you can give different meaning based on the situation we're talking. can talking about the cost, can talking about the height, can talking about the temperature, all those kind of things. But when we use the different letters, we can easily link to the situation. So it's easier than just using y. Let's check one example here. Well, if we know the function is negative 3x plus 2, we know it's actually a line. Now, how do we find the values here? Again, you can pause here to figure out the answer. Some of you probably already figured out the answer here. So all we need to do whatever inside parentheses here is actually x, right? So all we need to do is replace the x in this expression with the value we have here. So f of 1 meaning x equal 1. So let's write out here as a reminder. So in this case, I just need to replace x as 1 here. So it's negative 3 plus 2 as negative 1. You can definitely continue to do that. I just do one more example as a reminder, as a review for you for this case. For this case, x equals, yes, you're correct, negative 2. So in this case, I'm going to replace x as negative 2. Whenever I say negative, I just prefer to put a parenthesis so I can avoid making mistakes. Negative 3 times negative 2 is, yes, positive 6 plus 2 is 8. That's it. So for this case, meaning f1 is negative 1, f negative 2 is 8. Meaning when x equal negative 2 is 8. When x equal 1, y is. Let me write it down here. So that's how do you interpret this function notation. You may wonder, this is like a pure fact. Yes, you're right, but once you make the connection between those two, it's easier for you to interpret different situations. Sometimes we might look at the graph. Sometimes we might look like a table. So let's check the table example. Okay, for this one, we have a table, function table, and the question asking us two. The first, find out f of 1. The second question is a little bit tricky because the second one is asking, what is x when f of x equal 10? Let's check the first one first. F of 1 meaning, what is y when x equal 1? So some students mention, I don't have equation. Do I have to generate an equation based on table? No. So that's a good part of using function notation. We just need to focus on, hey, when x equal 1, let's look for the value in the table. When x equal 1, what is y? Y is 2, matching to 1. So in this case, what is 2? Make sense? So for example, let's check another one. If I want to find f of 3, all I need to do, I know x is 3, so I need to look for the x and match into 6. So y is 6. Let's check the second question. Second question is when x equal, what is x? So the question is for x when f of x equal to 10. Some student, my first reaction is, hey, I don't see x equal to 10 here. But remember, when f of x equal to 10, meaning when y equal to 10, what is x? So we're kind of looking backwards. So we are looking for that 10 for the y value, which is here. Let's use a different color. And then we're looking for the x value, which is this one. So x is 5. Yeah, that's it. So that's all I want to share with you today about function notation. We're definitely going to do more practice in the future. I hope this video is helpful. Thank you so much for watching this video. See you soon, everyone.